See, we are going to discuss about polyatomic compounds valency, okay? Valency of polyatomic compound. Polyatomic compound means the compounds made of more than one element. And there will be two categories basically. Type 1, when there is no oxygen, remember. No oxygen, that means in presence of hydrogen, compound made of hydrogen, okay? I am taking one example. First example. See, example, compound with NH3, say NH3, it is called ammonia, okay? NH3, ammonia. What will be its valency? How to find, you see? In this case, what is the nitrogen? Atomic number 7, we know. So, electron distribution will be 2 and 5. First shell we have discussed in the other video that it can hold maximum 2 electron. So, remaining will go to the second shell 5. And this 5 is called valence electron. Valence, spelling you will see it is correct or not, valence electron. Outermost electron in outermost shell is called valence electron. The other one is hydrogen, okay? Hydrogen only one, so it has only one in the outermost shell. Na? Now, how to find the valency of this compound, you see? This hydrogen valency here, it will be -1. Because in this case, hydrogen will accept electron. Hydrogen will accept electron. When hydrogen compound, hydrogen will accept electron, remember. Huh? You remember like that, hydrogen will accept. So its valence will be to make outermost shell fully filled means outermost shell 2, it will borrow 1 electron, 1 plus 1 is 2. So hydrogen valency how much? It is accepting electron means valency is -1. Now how to do the calculation, you see? It is done like this calculation. Hey, valence electron of other element. Valence electron means outermost electron. How many? +5 in the outermost shell, plus valency of hydrogen is -1. And hydrogen how many times? Hydrogen 3 times, so multiply by 3. I am telling you again, valence electron of other element nitrogen. Valence in this case, valence electron of nitrogen how many? 5. Valence electron means electron in outermost shell. So 5. And valency of hydrogen in this case -1, because in this case hydrogen will accept. When remember compound with hydrogen, it will be hydrogen valency will be -1 3 times. Now I'll calculate, you see, +5 -3. So I am getting +2. This means NH4 ammonia valency is 2 positive. It has 2 positive ion. Valency is 2 positive. We write like this, okay? Ammonia. Then I'll take another example. Another example, here it is with no oxygen. Now I'll take another with oxygen. Try to understand clearly, okay? With oxygen, I'll take say OH. Second type, with oxygen. Whenever oxygen is there, you remember, you will do like this. OH, it is called hydroxyl. Hydroxyl, okay? What will be its valency? How to find, you see? In this case, hydrogen, see, before hydrogen, it was accepting electron, valency -1. Now, hydrogen will donate electron. Hydrogen will donate now. Its valency will be positive. You see. So, remember, when oxygen not there, only hydrogen valency, hydrogen will be negative. And when oxygen is there, hydrogen valency will be positive because it will donate electron now. So, hydrogen only atomic number 1. So, outermost shell only 1 electron. Oxygen atomic number 8, so it will be 2 and 6. So now in this case, hydrogen outermost electron, valence electron how many? 1. Hydrogen valence electron. And oxygen valence, whenever oxygen is there, you remember oxygen valence. Oxygen, it will take another 2 to make 8. Na? So oxygen valence how much? Oxygen valency is -2 because it has to take 2 electron. It is accepting 2 electron, borrowing 2 electron. So what will be the calculation now, you see? In this case, oxygen valency. So valence electron of hydrogen 1 +1 plus oxygen valency is -2. And how many oxygen are there? Only 1 oxygen. So 1. Valency of hydrogen, valence electron of hydrogen and valency of oxygen, okay? So you see it is +1 -2. So final answer is -1. Therefore, hydroxyl OH, it has 1 negative. 1 generally not written, you will just find they write it like this, OH minus like this. So you see, when hydrogen is there, I am telling you again, when hydrogen is present, no oxygen, then hydrogen will have positive valency, and you are taking a valence electron of other element, here valence electron of nitrogen, outermost shell electron nitrogen, and valency of hydrogen, and hydrogen 3 times here, multiply by 3 and calculate it. And when oxygen is there, then we have to take valency of oxygen and outermost electron, valence electron of other element. So here hydrogen valence electron means electron in the outermost shell only 1 positive, and oxygen valence is negative, and oxygen here only 1 time. So finally we have got the valency of OH. I am explaining more, you see. Next, now we'll take some examples. Say ammonium NH4. Ammonium NH4. What will be its valency, you see, NH4. Here oxygen is not there. So hydrogen will have negative valency here. When oxygen is not there, hydrogen will have negative valency, and we will take valence electron of nitrogen. Nitrogen atomic number is 7. So if we distribute, it will be 2 and 5. So valence electron, how many? It is 5. And hydrogen, in this case, it will accept electron, okay? Hydrogen, when oxygen is not there, hydrogen accept electron, valency negative. Only 1, so it will have only 1, so it will borrow 1 electron to make it 2. So hydrogen valency how much? In this case, hydrogen valency is -1 because it has borrowed electron. Now calculation, you see, valence electron of nitrogen plus valency of hydrogen is how much? -1, and hydrogen is there 4 times, multiplied by 4. So calculating, you see, +5 -4, remaining 1 positive. So therefore NH4 valency is 1 positive. 1 positive. 1 they generally don't show, they show like this, NH4 positive, 1 positive ion. NH4 1 positive ion, okay. Then another I am taking NH3. NH3 I have discussed already. NH3, then I'll discuss again. NH2. When NH3, it is ammonia. NH4 is ammonium. This is called ammonia. See, here again oxygen not there, so hydrogen will have negative valency. Nitrogen 7, 2 and 5. Hydrogen only 1, so it will borrow 1 electron. So here valence electron is 5, and this valency will be -1. Hydrogen valence will be -1 because in this case it is borrowing electron. Now calculation, you see, valence electron of other element nitrogen 5 plus hydrogen valency is -1 into hydrogen how many times? 3 times. I am telling again, remember, when oxygen not there, then hydrogen valency you will take negative, okay? And valence electron of other element plus valency of hydrogen. And hydrogen how many times? 3 times. So +5 -3, valency is +2. Therefore, NH3 ammonia valency is 2 positive. You see, it is positive. I am taking some more elements. See, OH we have discussed already. When OH? No, we have not discussed OH. I am explaining hydroxide. OH. OH we have discussed already, okay? In the first case, when oxygen is there, hydrogen will be positive, remember. When oxygen is there, hydrogen will have positive valency 1. When oxygen not there, hydrogen will have negative valency 1, -1, remember. Nitrate, I am taking next compound, polyatomic compound nitrate, NO3. What will be its valency, you see? Here hydrogen not there, so oxygen negative valency. Nitrogen 7, 2 and 5. Oxygen 8, it will be 2 and 6. So oxygen will borrow 2 electron to get 8. So oxygen valency is -2. And here valence electron is 5. So it is done like this. First is valence electron of other element, positive 5, plus valency of oxygen is -2. You remember, when any compound of oxygen, you will write first valence electron. This is valence electron, this one. whatever is here, this one is coming here. Valence electron of other element plus valency of oxygen. Valency of oxygen is -2 because it is borrowing 2 electron. Multiply by oxygen how many times here? 3 times. So you see, +5 -6, remaining -1. Therefore, NO3 nitrate, it is 1 negative. 1 generally not writing here. It is just writing like this, NO3 -1, okay, minus like this. So this is about NO3, na? How to find polyatomic compound, okay, valency. Then I am taking nitrate, NO2, you see. Nitrate, NO2. How to find valency, huh? Nitrogen, is it visible? Yes. Nitrogen 7, so 2n5. 2n5 is 7. Outermost electron we have. This one we have to take, huh? And oxygen 8. It is 2, 6, so it is borrowing 2 electrons, so valency of oxygen here is -2. And what will be calculation now, you see? 5, valence electron of nitrogen plus valency of oxygen is -2, multiply by 2 because oxygen 2 times in nitrous, NO2, nitrate, NO2, NO2, nitrate, nitrate, its name is nitrite, NO3 is nitrate, NO2 is nitrite, I. So here it is 5 minus 4 is +1. Therefore, NO2 valency will be +1. 1 if you don't write also, fine. Now HCO3, you see, HCO3 again valency. Here, HCO3. Here oxygen negative, hey? Hydrogen 1, valence electron 1, okay? Carbon 6. 2 and 4, valence electron 4. And oxygen we have just discussed several times, 2 and 6 borrowing 2 electrons, so oxygen valence is -2. So how will calculate, you see now? Calculation, hydrogen valence electron 1, another element valence electron 4, and oxygen valence is -2. And oxygen how many times? 3 times. Multiplied 3, hey? So 1 plus 4 is 5, -6, valency -1, you see. Therefore, HCO3, it is called hydrogen carbonate. Hydrogen carbonate, its valency is -1. Negative, just write minus, and to understand you can write -1 also. -1 generally not shown, okay? Now, another you see carbonate CO3 next, here. Carbonate CO3. CO3, how to find, you see, carbon 6, so 2 and 4, valence electron 4, we will take valence electron. Oxygen 8, 2 and 6 borrowing 2 electron, valency is -2. So valence electron, this number will come here. Valence electron is 4 plus positive, and oxygen valency -2. Oxygen how many times? 3 times. So it is 4 minus 6 -1. So valency is -1. Visible, I think. So CO3 valency is a negative sign. You can write -1. Actually in book they don't write minus sign. So this is carbonate. Now another problem is with sulfur, okay? Sulfur compound, you see. I'll discuss here about sulfur. You see, problem with sulfur compound, sulfur valency is -2. S. Sulfur, we have 3 different. Sulfur, we call sulfur has 2 negative. SO3 is called sulfate also, 2 negative. Sulfate. Sulfite. SO4 is sulfate. It is also 2 negative. This, see, SO3, just now the rule we have discussed. The problem is all the compounds of sulfur, you cannot find valency like that. Polyatomic. These are called polyatomic compound when more than one. This is element. Sulfur 16. Okay. Sulfur 16. Na? Sulfur 16. So if you distribute electrons, it is 2, 8, and 6. So it has to borrow 2 electrons. That's why -2. 2, 8 to make it 6. Another 2. 2, 8, 6 is 16. Na? So to borrow 2 electrons. So valency is -2. We have discussed before how to find valency. Now, so all the compounds of sulfur, valency finding, the process we have just now discussed, it is not giving, it actually fail. Actually there are so many other methods also, other ways are there to explain. This is just a simple idea of what I have discussed. You don't have to memorize anything, only this one memorize. Na? sulfur, any compound, SO3, SO2, SO, even SO2 also, na? SO2 also is there. Some cases, their valency will be all 2 negative, sulfur compound, okay? Any compound of sulfur, remember, even sulfur also valency in 2 negative, SO3 2 negative, SO4 also 2 negative. This one you will memorize. This SO4, if you calculate by the process we have not done, just now done, you will get the answer. You see, I'll show you. Sulfur how much? 16. 16, so it will have 2, 8 and 6. So valence electron 6. We have to take 6. Oxygen just now we have discussed 8, 2 and 6. So plus borrowing 2. So oxygen valency is minus 2 valency. Na? So calculation will be like this. Plus 6 and valency oxygen minus 2. Oxygen how many times here? Say SO4, na? 4 times. So 6 minus 8, it is minus 2. So you see SO4 valency is 2 negative. But if you find SO3 by this method, it will show wrong. Actually, this SO3 also has valency 2, but it is done in other method. So you just remember, any compound of sulfur, even sulfur itself, they have valency 2 negative, okay? And this is all about the finding the valency of polyatomic compound. Only this one memorize, other things, just the way I have shown the calculation, you do like that.